Thank you everyone for joining us today to ITS Michigan's Lunch and Learn. We have started these a while back, and during COVID, they found a way to go virtually. And now that we've come back to normality and things are kind of working out after a very busy 2025 year, we thought we'd start them back up in 2026. And we're super excited about our ITS Michigan Lunch and Learn / podcast version of this, because this will be posted online and you guys will be watching this virtually. For us to kick off the year, we were thinking of different topics, and one of those that came up has always been something that we discuss on our board meetings that occurs every other month, 6 times a year. And our good friend, Perry McNeely, always joins us, and he's always bringing in a lot of the latest and greatest when it comes to the state of the practice, the state of the legislature, and the state of the art of what's coming up next, especially from a legislation perspective and some of the lookout for what's coming next. And with that, I reached out. I was like, all right, let's have a quick conversation. Let's turn that into a lunch and learn. And this is how today cultivated. We've had to postpone it once, but we're super excited about having this moving forward. So again, good afternoon and welcome to this amazing discussion. I really want to thank everyone for joining us and others that will be watching this online. Today's session is titled Engineering Trust. EAB, so that's for emergency braking, V2X, which is vehicle to everything, and new architecture for ADAS technology that goes on vehicles. And this focuses on the question that is becoming central to the work that we're doing across transportation, infrastructure, and vehicle systems. And essentially, in today's world, it's hard to kind of separate ITS from the general idea of advanced driver assistance systems or some of the other automated vehicular elements that come within the vehicle. So we know about connected vehicles that have made their way into the ITS world, but more and more we're seeing the other elements of ADAS and automation becoming part of the ITS footprint. And this impacts everyone from drivers to engineers to regulators, operators, etc. So I'm very pleased here to have with me today my good friend and amazing ITS Michigan member, Perry McNeely. And Perry has spent years working at the intersection of vehicle systems, policy, and infrastructure. And he brings a perspective here that goes beyond the features of hardware. Just to look at ADAS, the evolving idea of trust, and how can you architect trust within those, and is there something that we can do from our own perspectives? And we're going to try to hone in on 3 of those elements, because obviously we can talk about all sorts of different things, and we're focusing on the 3 ideas of AEBs, V2X, and ADAS. Additionally, I wanted this conversation to be specifically relevant to ITS and ITS professionals. And with the help of Perry, I'm hoping that we can achieve this. Perry will give us a brief presentation for the first half of the hour, and then we'll move it into some sort of a Q&A. I've prepared some questions, and I would love to kind of hear from the people that are with us on this recording. Please feel free to put in any questions that you have in the chat as well. That will help us move things forward. And if for some reason there was anything that you'd like to chime in, there will be an opportunity to include that at the end. So again, we don't want to keep on operating in different silos. We want to bring this all together, and I believe this conversation will help us, with Perry's help, and maybe taking that first step towards how can we actually try to bring everything together, and how can we start building this trust moving forward. With that introduction, Perry, I see that you're off camera right now, but if you can turn your camera back on, that would be great. If not, we're all ears, and we're looking forward to your presentation.
Okay, let me see about the camera. Yeah, I don't think I can do the camera right now, but I'll start the presentation, then turn the camera on.
Sounds good. And Perry, please feel free to, if you would like to introduce yourself first and give us a little bit of background of how you got to putting all this together. And maybe before we start, can you tell us a little bit more about that?
Well, yeah. I've been retired about 7 years from Ford Motor Company. I worked in the research lab there for 35 years. The first half of my time there, I spent working on structural analysis and especially on computer systems. And as those became kind of commodities, I moved into what we called then embedded systems. And that grew into what is now ADAS. So I've worked with that for about 20 years. And since retirement, I've kept up with the legislative aspects. So I do the legislative reports for ITS and keep an eye on what the government is doing and what the regulators are doing. And this is kind of a shift from, getting deep into the technology, which is what I did before. So that kind of led me to this presentation because I was trying to come up with a way to show how the two sides of ITS, which I think of as infrastructure and automotive, come together conceptually under the rubric of trust and trust engineering. And trust engineering is a cutting edge field that it's been studied in the past, but is coming into focus because as systems get deployed, trust becomes a bigger issue. And so that's kind of the goal of the presentation. ADAS, for many years, a lot of the discussion centered on a lot of the discussion around ITS centered on sensor performance, processors, networks, software features, and human-machine interfaces. These topics still matter, but I think cutting edge is moving toward a different question. How do we build systems that are trustworthy enough to deserve authority? So now cars make decisions for us. They put on the brake, they put on the brake when they override the human and put on the brake when they think it's needed. How do you, how can you trust them to do that correctly? Or in the case of, say, infrastructure equipment, automatic license plate recognition may trigger law enforcement action. How much can you trust them to do this? And when does the human need to intervene? And since there's a lot of equipment and a lot of technology involved, a methodical approach to trust is needed. From sensors to statutes, this field is moving from a world in which the main question was what systems can sense toward a world in which institutions are increasingly asking what systems are allowed to do, what evidence they rely on, and how their decisions are governed, how their actions can be explained later. I will use AEB as a concrete ADAS example because it is familiar, important, and now tied more directly to regulation. But the larger point is that broader than AEB, it includes vehicle data, local V2X safety meshes, smart road deployment, and supply chain trust. My basic argument is this. The ADAS debate is shifting from what systems can sense and how institutions govern what systems sense, sign, share, and decide, remember, and sustain. That shift matters because the audience for ITS is diverse. Automotive engineers, infrastructure engineers, university researchers, public agencies, and suppliers often look at different parts of the problem. Trust modeling offers a way to connect these pieces into one architecture. So this is not just a talk about one law, one feature, or one technology trend. It's a talk about the broader problem of how modern transportation systems earn trust. This graphic is the backbone of the talk. It shows that trust in ITS and ADAS is not just a matter of what the system can sense in the moment. Trust has to run through the entire chain. It begins with sense. The system has to gather information from cameras, radar, roadside units, maps, or other sources. That is where most traditional engineering discussion begins. But then the next step is build. And I want to emphasize that step. A system cannot be trusted if we do not trust how it was built, its components, software, firmware, provenance, and supply chain. That is why supply trust belongs in the same architecture as data trust. Next in the chain is sign and transmit. Once information is produced, especially in a V2X or distributed system, it has to be packaged, authenticated, and moved. The question is no longer what does the system see, but what is being asserted by whom and over what path. The next step is verifying. The system has to decide whether the data is authentic, timely, relevant, plausible enough to use. This is where trust modeling begins to look like evidence-based reasoning. Only then do we get to decide. The system must decide what authority its evidence has earned. Should it warn, assist, intervene, defer, or do nothing? It has to choose what actions to take. After that comes maintain. And this is an important step too. A system that cannot be updated, patched, requalified, supported, and sustained over time is not fully trustworthy, even if it worked well on day one. Finally is audit. If the system cannot retrace its step, explain what evidence is used and what justified why it acted, then it cannot fully earn trust. So the main point of this graphic is that trust is not one box in the architecture, it is a chain. And if any link in the chain is weak, the authority of the whole system will be limited. For the bottom three boxes, why it matters. Each section of the talk contains section of the talk connects a law, policy issue, or engineering practice back to a trust chain. I do not want this to feel like a list of unrelated legislative developments. The point is that regulation, procurement, validation, cybersecurity, and operations are all starting to press on the same underlying question. What part of the system is trusted, for what purpose, and with what authority? I have highlighted build and maintain because those steps are easy to overlook. Engineers often focus on sensing, messaging, and decision logic, but supply chain, substitution, patching, lifecycle support, and requalification are now part of the same trust problem. A system that was trustworthy on day one may not regain trustworthy if components change, patches lag, or support disappears. And finally, the audience payoff. This matters for a mixed ITS audience because each group can find itself somewhere in the same chain. Automotive engineers may focus on sensing and control. Infrastructure people may focus on roadside systems and operations. University engineers may focus on methods, validation, test beds. The trust chain framing lets everyone hear the talk as part of one shared architecture instead of someone else's topic. So the trust modeling becomes the architectural glue that holds the different stakeholders together. So this slide answers the question, why is this worth talking about now? My argument is that several developments that used to look separate are beginning to converge around one issue: trustworthy deployment under real-world constraints. The first box is ADAS regulation. FMVSS 127 turned AEB and pedestrian A and B into a compliance object. This is where actually federal legislation requires automatic emergency braking and pedestrian automatic emergency braking in vehicles by 2030, I think. That matters because once a function becomes regulated, it no longer is just an OEM feature or a research topic. It becomes something that has to be validated, documented, and defended. The second box is connected vehicle governance. The question is no longer only who can read vehicle data, it is who can design, update, export, receive, or rely on that data and software stack. That pushes trust questions into software provenance, cybersecurity, privacy, repair, and national security policy. The third box is spectrum and V2X rules. The FCC has now codified the current USC V2X framework for the 5.9 gigahertz ITS band. That means local safety messaging and connected vehicle deployment are no longer just technical possibilities. They now sit inside an actual regulatory and governance structure. The fourth box is deployment reality. Smart road decisions now live inside funding, procurement, integration, cybersecurity, and operations and maintenance. In other words, this is no longer just about pilots or demonstrations. Agencies and operators have to decide what they are willing to buy, govern, sustain, and explain. The big panel at the bottom is the takeaway: trustworthy deployment under real-world constraints. ADAS can override the driver, so the question becomes, can it be trusted? V2X allows vehicles and infrastructure to exchange information. So the next question is, can that data be trusted? Once you ask these questions, seriously, you realize that the field needs stronger engineering disciplines for designing trustworthy systems and stronger supply chain policies for building and sustaining them. This slide is really the bridge from policy to engineering. It says that recent changes in regulation, connected vehicle governance, spectrum policy, and deployment practice are all pressuring the same weak point: how much authority these systems have earned. This slide marks the first major shift in the talk. ADAS is no longer just a promising feature set. It is becoming a compliance object. That is why FMVSS number 127 matters so much. Your slide correctly frames it as the pivot point. NHTSA's 2024 final rule requires automatic emergency braking and pedestrian AEB for light vehicles, which moves the discussion from optional OEM feature strategy into federal compliance, validation, and documentation. The deeper point is cultural. For years, a lot of ADAS work lived in a research concept or pilot mindset. Once government starts regulating a function, the culture changes. Teams begin to think less in terms of demonstrations and more in terms of production pipelines, traceable requirements, repeatable tests, and auditable records. That is what this slide is getting at when it says compliance pulls features into a production-oriented environment pipeline. This also changes the style of innovation. Instead of a purely moonshot style, a full autonomy all at once mindset, the field becomes more incremental. That does not necessarily mean it is less important. In some ways, it makes it more consequential because incremental regulatory pressure can normalize product design choices across the industry over time. This slide makes that point by contrasting a holistic moonshot approach with the continuous incremental change that may eventually produce a paradigm shift. This slide is my real-world automatic license plate recognition example. And I use it because it makes the trust problem concrete very quickly. The image on the left was mailed to me in December for a segment of a trip I took across New York on the Thruway in July. The location has been intentionally obscured for security reasons in the letter I received. The image is supposed to show my car passing under a gantry and that I owe $12 in toll. That seemed plausible, but the image itself does not really prove it. I had already received earlier bills for other segments of the trip. The segments sort of came in a bit at a time. And from the information provided, I inferred that roughly half the charge went to the toll itself, and the other half went to administrative costs of collecting the toll. The immediate consequence here, in this case, was small. I paid it, but the point of the slide is that the weakness of the evidence is obvious. And if the consequence had been larger than $12, the weakness would matter much more. That leads to the broader point. Many deployed ALPR and camera-based systems show the same symptoms: high exception rates, heavy manual review burdens, error disputes, fragile user interfaces, security vulnerabilities, legal challenges, and difficulty explaining mistakes. These are not isolated defects. They are signs of weak trust architecture. The core problem is not that the camera makes recognition errors. The deeper problem is that the system often does not clearly model where the data came from, how reliable it is, what conflicts exist, what uncertainty remains, and what action level is justified, and what explanation must be preserved. That is what I mean by the trust model gap. The highlighted box at the bottom is really the punchline for the slide. Many camera and recognition systems were built under a deploy first logic, capture data, connect feeds, add analytics, and deal with reliability, security, and governance later. That created not only technical debt, but trust debt. The result is visible in manual review burdens, disputed tolls, brittle workflows, security exposure, and public distrust. So the reason I use this example is not to complain about one tolling system. It's to show that when trust modeling is weak, automation does not disappear. It reappears as manual review, disputes, exceptions, and difficulty explaining why the system acted the way it did. This slide makes the trust model idea operational by using ALPR as the example. The first point is that a recognition is not a neutral event. Once a plate is recognized, the system may take many different kinds of action. Some are low consequence, such as storing data for congestion modeling. Some are medium consequence, such as forwarding an image for manual review or generating a toll bill. Some can be much higher consequence, such as notifying law enforcement, operating a security gate, or enabling access to restricted property. That means the central question is not simply, did the system read a plate? The real question is, what level of authority has that recognition earned? Before any action is taken, the trust model has to answer several questions. First is device trust. Can the camera, hardware, and software be trusted to faithfully render an image and deliver complete data? The second is pipeline trust. Was the data modified in the network, misrouted, lost, delayed, or counterfeited? Third is data provenance trust. How reliable is the data under the actual conditions in which it was collected? Lightning, weather, angle speed, and occlusion all matter. Fourth is hypothesis generation. Am I even testing the right possibilities? Have I considered alternative explanations, or am I allowing the system to narrow the field too quickly? The fifth is accuracy and consequence. What confidence is attached to the recognition or measured value, and what are the consequences of a false positive or a false negative? The panel on the right explains why retracing steps matters. A trust model has to be able to retrace its reasoning so the decision can be explained, challenged, improved, audited, justified, and helps engineers debug failure, helps institutions assign responsibility, helps reviewers see uncertainty instead of hiding it, and helps prevent over trust in automated outputs. So the big idea here is that recognition alone is not enough. A trustworthy system must be connected. Recognition, a trusted system must connect recognition to justified action, and it must preserve the reasoning path that led there. This slide makes the point that supply chain trust is part of the operational trust. We often treat procurement as a cost and availability issue, and then talk about trust later as a software, cybersecurity, or policy issue. My argument is that those cannot really be separated. On the left are examples from ADAS in the vehicle, the forward camera, radar, compute module, connectivity module, firmware or model package, and braking path electronics. On the right are the matching examples from ALPR and tolling infrastructure, the plate, camera, lens, illumination, edge processor, networking module, firmware or OCR software, and the storage or back office interface. The important parallel is that in both cases, one case being in the car and one case being in the infrastructure, the same question has to be asked. How much authority should this component be given? In the ADAS case, that authority may range from low consequence uses like driver information to warning, to intervention, to automatic control. In the ALPR case, it may range from traffic observation to toll invoicing, to exception handling, to enforcement or evidentiary use. So the issue is not just whether the component works in a general sense. The issue is whether it can be trusted for this function at this consequence level. That shifts the conversation from, is this component available, or does this vendor meet spec, to a deeper question. What type of reliance has this component earned? A forward camera feeding AEB and a plate camera feeding toll may seem like very different technologies, but they raise the same trust problem. In both cases, the component sits upstream of the consequential action. If the component's provenance, firmware, update control, lifecycle support, or qualification are weak, then the finished system may be given more authority than it deserves. This slide is really a bridge. It says that the same trust model can be applied across automotive and infrastructure. The supply chain is not outside the trust model. It is one of the first places where trust is decided. This slide answers the next practical question. What should a component have to prove before it earns authority inside the system? The first test is provenance. We need to know who made the component, who integrated it, who wrote the firmware or the software. What matters because that matters because trust begins before operation. If provenance is weak or opaque, the component may already be starting from a trust deficit. The second test is configuration integrity. Has the system booted in a known good state? Is the firmware signed? Do we know that the configuration is actually running? The component may come from a reputable source, but if its configuration integrity is weak, it can still become untrustworthy part of the system. The third test is update and patch control. Who can update it? How quickly can vulnerabilities be corrected? How can old vulnerable code persist in the field? This matters because trust is not static. A component that was trustworthy at deployment can become less trustworthy if it cannot be maintained securely. The fourth test is performance qualification. Has the component been tested in real use case? What are its failure modes and drift modes? What happens in degraded conditions such as weather, glare, vibration, contamination, or unusual traffic scenarios? This is where supply chain trust and engineering validation start to merge. The fifth test is substitution and requalification. If supply changes, can we replace the component safely? How much retesting is needed? This matters a great deal right now because many organizations are dealing with concentration of risk, obsolescence, and outsourcing constraints. A substitute part may fit physically, but that does not mean it has earned the same operational authority. The sixth test is life cycle support. Are spare parts available? How long will the vendor support the product? Is obsolescence likely to create hidden risk? A component that cannot be supported over time may undermine the trustworthiness of the larger system, even if it performs well initially. The seventh test is auditability. Can we reconstruct what version was running? Can we explain what the component contributed to the final system behavior? This is especially important if the system later has to be debugged, defended, or examined in a dispute. So the principle at the bottom is really the main point of the slide. No component should be given more operational authority than its provenance, integrity, qualification, and lifecycle support can justify. That principle applies whether we are talking about a forward camera in an ADAS stack or a plate camera in tolling of ALPR system. In both cases, the component sits upstream of consequential action. If its foundation is weak, the authority of the whole system should be limited. This is this is the question I want to leave you with. Over the course of this seminar, I have tried to argue that the central issue in ITS is no longer only what systems can sense. The larger issue is whether institutions can govern what connected systems sense, sign, share, decide, remember, and sustain. We have looked at that problem from several angles. In ADAS, the question appears when a system is allowed to warn, intervene, or override the driver. In ALPR and tolling, it appears when weak or incomplete evidence is still given real administrative or operational authority. In supply chains, it appears when components, software, and lifecycle support determine how much reliance a finished system really deserves. So the through line of the talk is this. Trust is not a feature, it is an architecture. It begins with what is built into the system, extends through how information is signed, transmitted, verified, and used, and continues through maintenance, audit, and institutional oversight. That's why I think that trustworthy deployment is becoming the real challenge. Sensing and improving, connectivity is expanding, data is becoming easier to collect and distribute. But the difficult question is still, how much authority have these systems earned? And how do we know? For this audience, the question lands in different places. Automotive engineers may hear it as a problem of validation, fallback behavior, and explainability. Infrastructure engineers may hear it as a problem of procurement, roadside governance, and operations. University researchers may hear it as a problem of methods, test beds, and neutral validation. But I hope the talk has shown that these are all parts of one trust chain. So I will close with the line at the bottom of the slide because it is really the summary of the whole seminar. Sensing is getting easier. Trustworthy deployment is now the challenge. With that, I would be very interested in your reactions, especially where you think the trust gap is largest today in design, procurement, in operations, in regulation, or public acceptance. Okay, now I'm going to try to figure out
how to turn the camera back on. Awesome. While you're doing that,
yes.
I appreciate the presentation quite a bit, Perry. Thank you. And it opened my eyes to a number of different things. And I have a few follow-up questions for you once you're ready with your camera. And I've noticed we have a few additional friends that have joined us since you've joined. I do want to highlight a couple of things that really spoke to me while you were presenting. I think the three topics that I kept on kind of hearing, and I'm quoting you here, trust is not a feature, it's an architecture. I really love that statement. I like the idea of it's a one trust chain. Like you can't just kind of say, I'm basing this trust based on, these three parts of the chain, because if one or two are broken, then essentially that trust chain is broken, and sensing is getting easier. Trustworthy deployment is now the problem. So I just want to hit on some of those. If any of our friends here on the call would like to put in some questions in the chat, if you want to raise your hand for some questions or input, please, by all means. It doesn't need to be a question. If you have a personal experience you'd like to share, please feel free to go ahead. And while this is happening, I'm going to ask you my first question about trust is not a feature, it's architecture. I love how you've framed it, but do you build it and they will come? Do you build the trust and people will show up? Or should you try to build the products and then fill in the gaps of where trust is missed? Because I don't feel like we can fully see, especially now with AI, et cetera, fully see where all the gaps are coming. Where do you feel like it's coming? Is the horse or the cart or the chicken or the egg coming first?
Well, AI, of course, has similar trust problems. ADAS is kind of viewed as maybe an alternative to AI. ADAS is kind of the more incremental approach. AI tends to be a moonshot approach. And but AI has the same problem. It's not auditable, for example. So it makes a decision, but it takes a great deal of effort to figure out how it made that decision. And so when the decision has consequence, like if a autonomous vehicle has an accident, figuring out what the mistake was and how to engineer it out is very difficult. And so I think a certain level of transparency is important, but also developing trust models. So on the automotive side, where I mostly worked, originally we used FMEA for reliability modeling and robustness. And FMEA was designed by NASA as a methodology for making systems robust by anticipating the things that could go wrong. So it was designed around the idea of rockets going to the moon, and you can only send up a few rockets, so you can't do a lot of testing. So you have to do, what could go wrong? How will we deal with that when it does go wrong? And it was popular in medical devices and aerospace. It's been used a lot. So in the car companies, if something went wrong, like the anti-lock brakes didn't work, the regulators would ask you for your FMEA. And this was in a standard form, and it's part of ISO 9000. Then things moved to Agile. And with Agile, you put out a product that may not fully be tested, and you wait till users find the problems and then report them and you fix them. And so you're in a constant debugging loop like that. But trust isn't high in that. And so you may not really want to use that for anti-lock brakes or something like this. So what I'm proposing here is that the work needs to be done on developing trust models that are useful for all elements of ITS. So an electrical engineer can understand the trust model developed by by an automotive engineer or by a pavement engineer or something like this, that you have a uniform language for describing trust. And it also has to hold up to scrutiny by, politicians and lawyers. It could wind up in litigation. So I don't think these trust models exist yet. I think there's people working on it.
Okay.
And that this is really the challenge.
So you bring up a great segue into the next part of getting the trust across the different elements of the decision-making element before it gets to the consumer itself. So let's say we're talking maybe vehicles, but this could be applied to any ITS system, to any AI system, maybe even automation beyond ADAS. But do you feel like the legislation body and setup is built to understand the technology as well as it should be? Because again, I feel like we're selling trust first to maybe some of our legislators before the public or the engineers.
Well, I think the legislators are new at this, that most of the regulation has been done up till now in the administrative branch of the government. It's all part of the Department of Transportation and Department of Commerce and this sort of thing. But as the responsibility for legislation moves to Congress, which seems to be happening, Congress is going to have a way of discussing this. So politicians are going to need some way of talking about trust so that they can write regulations that make sense.
Okay, so based on that chain that we discussed, and I loved how you kind of went into all these different elements that will lead to that final trust. Where, in your opinion, do you feel like is one or two of the weakest links that need to be kind of tightened up a little bit more?
I think coming up with agreeing on a sort of a rigorous mathematical foundation for trust modeling is important, and it needs to be mathematically provable. And this doesn't mean that the people who use it need to be able to do the proofs, but it needs to have mathematical reliability. And then it needs to be dispensed in a form that is really usable by people practicing in the field. It should be understandable without too much effort by citizens, and in greater depth by specialists like lawyers and engineers. And I think actually one thing we might think about is how to educate the next generation to understand trust modeling. I think a simple approach is to start with evidentiary methods, because we tend to be familiar with we tend to be familiar with the way courtrooms work and the way rules of evidence work. And I think also voting systems, like people need to have a better understanding of how voting systems work, their strengths, their weaknesses, et cetera. And so what you're going to do is combine data from lots of different sources, and each piece of data is evidence, and each piece of data has a certain confidence level. And how do those confidence levels combine? Well, this can be done rigorously mathematically, but it also can be done intuitively. And that this kind of training could be combined with, say, civics education for children. So we have a new generation that knows how to reason in this way.
Critical thinking, common sense. I know I have a good mentor of mine that once mentioned artificial intelligence is neither artificial nor intelligent. So sometimes you have to just kind of look at what you're being presented with and just kind of critically be able to kind of reason through it. I think it's something that maybe was hammered into our heads in engineering school and in the very, I would say, rigid previous way of doing things. it's okay to kind of relax a little bit, but I feel like, and maybe you would agree or disagree with me on this one, my red line, my line in the sand that I would never cross is when you're taking risk or safety, people's safety is at hand. I feel like if it's additive systems that add safety or like ADAS, that's great. But when it comes to complete automation, I feel like sometimes I worry about the safety of this. And I'll let you chime in on this because I have something to maybe share on what our Detroit experience was in that era. Please go ahead, Perry.
Yeah, no, I think that's a big problem, that these systems are making safety decisions. So one thing that's kind of come into common use is electronic stability control in cars. So when the car determines the need is there, it uses differential braking to correct the path of the car so it doesn't roll. But how does it really know when to engage that? You know, and how does it really know what decisions to make? Like, yeah, a driver might say, well, I'd rather roll the car than hit the pedestrian. But the adaptive, the electronic stability control can't make those kinds of decisions. And so I think that's just the problem, that, we need to develop systems that have more inputs. They would say, well, we've got a pedestrian ahead of us. There's going to be a loss in this. Like what loss is the most acceptable?
Right.
And you see this in movies, like iRobot was like that, the robot comes and it rescues the guy, but the guy wants to rescue the person in the car. And, and so the robot makes the choice for him, but it wasn't, even though it was a mathematically good choice, it wasn't the choice that he wanted to make.
Yep. And the human element in this world, or this decision-making world, is very interesting. If we are to apply that again to vehicle automation or connected vehicles, which we kind of hit on today, I feel like that the problem exaggerates in a certain way because now there's infrastructure involved and there's some decisions that go beyond the vehicle itself. Like with connected vehicles, you are getting information from the infrastructure, from other vehicles, from almost everything that's around you. And the vehicle now is put in a position to have to kind of filter through all this information through obviously some very smart algorithms that the OEMs have created to try to decide what it can and should be deciding to give the driver some information, or if it's in automated mode, for it to kind of act upon those. So I know that there's things like, signal status through SPATs, vulnerable road users, other vehicles, speed, potential roadway obstructions. All of that is kind of being fed into the vehicle. And you bring up this great point about then where does the decision lie and what kind of decision is there? So recently we saw some of the videos around Waymo that where the Waymos had just stopped in the middle of the road because they didn't know how to navigate around each other, and it created gridlock in San Francisco. So I believe this is the part that chips away on some of the trust that falls into some of those systems if they're not demonstrated in a way that meets what our expectations as humans are. I know my mom would have gone on the sidewalk and just cleared up everything in a safe way, obviously. But we do decisions. We make decisions as humans that may not necessarily jive with machine thinking.
Yeah. So I mean. Self-driving cars like Waymo are being proven by exhaustive proving, right? You keep driving them and driving them and driving them, and things go wrong, and you fix them, and after a while, you assume that no new things will go wrong. But when can you make that assumption?
Until you've tested them with some ducks crossing in front of the road or something that you hadn't accounted for. But just in all fairness, I think Waymo has taken a very bold move in taking us a step closer to that vision of the Jetsons with, vehicles kind of taking us where we want to go. And they're doing their due diligence when it comes to safety, but there's still those edge cases that are coming up that are proving that we have to continue to engineer our way out of things and common sense our way out of things. Perry, I do see a question from Partha. So let's pause for a quick second. Okay. And Partha, do you want to unmute and chime in?
Yes, please.
Go ahead.
So yeah, no, I just wanted to go back to this the issue about trust, and I think it's for this time it's extremely important, not just in any specific area like ADAS or application of AI or even ITS. The reason is, AI is not just making decisions that, like you said, we don't always understand, but also we are collecting boatload of data pretty much in every aspect of vehicle development, the vehicle feature deployment, you name it, okay? And what struck me a few days back, I was at a D-Space event, their users event, and Cavnew, a company that works in ITS, they install and process camera data from the road so that they can predict an evolving hazard on the highways. Okay, that's the idea. But then the question of trust came because they are looking at cameras and they're interpreting a lot of different events that's happening on the road, and they have all those data. So question was, where is all that data going? And who's using it? How long is it going to be there? How does it, relate to people who are just using the road, just to be using the road? They have nothing to do, but they are basically caught in that data collection net, right? And your point about the fact that the trust needs to be and should be modeled mathematically so that it can be applied in a court of law. For me, the keyword is transparency. Okay, whether I'm a car company, selling features to consumers, or I'm an ITS system coming up with some kind of public related safety, process like this Cavnews. And I don't want to put Cavnew, as an example here because it's not them, it's really the whole process. But I think that transparency of who's using the data, what data is being used, and why is it being used, somehow that needs to be factored into all these things we are talking about end to end, whether Partha, it's a vehicle.
Spot on. I love it because just to kind of to your point, recently the Detroit People Mover went down because of winds and things that flew into it. The first thing they did was go to social media and put out messages saying, this is the problem with photos. This is what was going on. This is the issue why the People Mover's down. And we're doing everything that we can to bring it up to speed. I was like, I love this post. Next thing they did was, all right, we've cleared it up. We've identified this. Now they just put something, their final testing, and we're about to go live again. This adds a lot of value. So but I have a question for you, Partha. If you still have a minute, I'm not sure if you're still with us.
Yeah, no, I do. I actually joined pretty late because my partner, Ravi, he just sent me the link. Yeah.
Oh, no worries. And we have it recorded. It's going to be available out for others to watch. One of the things that we were talking about, and I'm going to quote my good friend Perry here, sensing is getting easy. Trustworthy deployment is now the problem. Partha, you are in the business of sensors, technology, data, and putting it all together, packaging it to be able to present some smart technology out there. Do you agree with that statement that sensing is now been figured out? We have enough sensors and we know how to figure things out. Now the big problem is stitching it together in a way that makes sense and trying to build that trust into the data and the findings and the elements that are there.
Absolutely. And it is related in so many different ways to not just the consumers, but people who are providing that service. Because like you gave some example about Waymo and Waymo doing things and they're not very clear. And we just came to, again, at the same event that you and I met, at the CCAT event, where there are a bunch of people talking about, what was it? The topic was about self-certification, right? And it's like, can an autonomous system be deployed just based on self-certification, or there has to be a more involved third party or government certification? And there was a mixture of opinions about it. And I talked to some of the panelists later offline, and my point was self-certification doesn't work. It has to be somebody
So
else doing it, right?
I was just watching a panel at CCAT last week, and they were doing like a debate with our amazing Henry Liu.
That's right.
And they were talking about should
Yeah.
it be self-certified or should it be scripted? And I heard
Yeah.
some really, I would say, very strong arguments on both sides, but I still agree with you on that one. So we're coming to the end of our time.
So my
Partha,
answer is yes.
Yes.
The
Okay.
question
But,
that you raised
one thing I would say about the self-certification is, this came up with Boeing recently with, what was it, the 737 MAX 800? That was
yes.
self-certified.
Yes.
And, the problem for industry is that Boeing wants to sell airplanes all around the world. If you're, say, the airplane regulator in the Seychelles Island, you probably don't have the resources to really know if these planes are well built, are properly engineered, et cetera.
Yeah.
So you're relying on the American FAA to certify the plane. If the FAA isn't part of the certification process, then maybe you go to Airbus instead, right? And you go to the European manufacturer. And so, I mean, this is another aspect of trust that it helps our industry to have trustworthy regulation. And I agree with you that it needs to be the regulators and the builders of the plane have to be two different people.
And it's a chain. I love that analogy earlier on. Like it's all tied together. So before we wrap up, I do have one quick question, and Partha, please be part of the answer. So in Detroit, before we put out our self-driving shuttle for older adults and people with disabilities, we did a very comprehensive automated vehicle engagement and investigation, try to understand how can we build people's trust in or rideability, or what is the willingness to ride on these shuttles. And we went beyond those. We went also with younger folks, like between 13 and 16, mostly because they can't drive, parents with kids, and a low income. And we tried to kind of look at some of those. Obviously, some of the biggest things that drove, we looked at race, age, elements, all these different things that we don't usually think about as engineers. But it was interesting because it just seemed like there were some factors that were playing into some of those. I'm going to give you the answer. Maybe this will be a great teaser for another time, but I have two questions for you. Do you feel like the technology is ready today for, let's call it automation beyond ADAS? Let's talk about automation, connected vehicle, and AI-driven mobility. And then the other part is, in your opinion, who do you think was the group that was least likely to ride on those shuttles, or least interested and had like the most concerns? So let's start. Is technology ready? Maybe that's a good, quick, easy answer.
Is that for me or?
Both. Whoever would like to take that first.
Which group?
So let's start with ADAS. I feel like you're comfortable with ADAS because it's more proven. Let's go to the one that's less I would say feet on the ground, with automation, automated vehicles, and potentially AI decision making for some of those elements. Do you feel like the technology is there today?
I'm feeling like probably the seniors are less willing to take on the technology.
Okay.
That just because they're not comfortable with that, they.
Okay. And Partha, do you have any thoughts?
I don't have a thought on the who would adopt it faster, if that was part of your question. But in terms of the technology readiness, I would say it depends on what we call ODD, the operational design domain, right? And the thing is, today, from an autonomy standpoint, if you go to mines in Australia or tar sand mines in Canada, there are Caterpillar fully autonomous tractors working. They've been working for years, right? But there is no traffic, no cross traffic, no people, no scooters, no uncertainty, right? So I think the readiness is a function of, the uncertainty of my environment. So if you look at a full urban downtown with all its complexity, and if I need to go from anywhere to anywhere, technology is absolutely not ready. But
All
if
right.
I'm saying, I have a defined geofenced point A to point B, yes, the sensor capability is all there. To a large extent, basic decision making is there. But again, it's not ready with all these potential edge cases that literally, spring up, in every single day that we don't know what they are. Like your example of Waymo, couldn't deal with when it was in a different environment.
So, quick final question. Have you guys been on a automated vehicle, on a self-driving vehicle without the driver inside? Perry, have you had okay.
Yes.
So you're comfortable with that. Would you be comfortable sending one of your children or your grandchildren by themselves on one of those vehicles?
I think I would. Yeah.
Yeah, but again, it's a point to point.
The ODD. There you go.
Yeah, it's not for anywhere. If I know that, there is from airport to the, wherever, there's a very specific point to point that they're running for, already been tested many number of times, and there is no other cross traffic. Yes, please.
Barry, I think Partha just made your point in terms of like building that trust architecture and that chain.
Yes.
I love it. I think we all kind of came to that converging point. We are at time. I want to say thank you so much for your time, gentlemen. And I know Partha, your input was amazing. Perry, thank you for being so generous with your information. And I look forward to seeing you at the next board meeting. But this video will be available online, so others will be able to
I would love to see that because I joined much late. Because I came to find out about it later. But I'd love to know that. Please send me the link when it's ready.
Absolutely. Thank you so much. And I do want to thank everyone with me at ITS Michigan Board, and especially Calvin Tuttle for making this session practically feasible and for helping us with the recording. Thank you, and we'll see you guys next time. Have a great day.